Ladies and gentlemen, we are starting name. My names are Douglas Onyango, and I will be chairing this segment of the program. What the session that we're going to have is going to discuss some two issues that have critical importance to internet infrastructure. To my right, we have Barry, who is from the Kenya Internet Exchange Point. He will be making a presentation about KIXP. And to my left, I have Mark with me, who will be making a presentation today about carrier grade NAT. The whole point, the whole idea behind this session is to discuss issues that are of critical importance around these two areas. So I'll be expecting a lot of participation in forms of questions from the members from the floor. At this point, I'm going to just get the program started because we are running slightly behind schedule already. So I'm going to welcome Barry to the floor and let him go on with his presentation. We'll have maybe one or two questions after Barry. We will have Mark's presentation, and then again another round of questions after Mark's, so that we get things moving quickly. Thank you very much.
Hello everyone. It's really hard to do a presentation after lunch when everybody is full, so I'll try and be brief as much as possible. My name is Barry Apudo Masharia. I'm the technical manager at Kenya Internet Exchange Point, which is managed also by TESPOC. My contacts are on the board. We'll go straight to the agenda. Somebody with the slides?
Next slide, please.
We'll have an introduction of what we do at the exchange, talk about the members of the exchange, talk about the services, peering policies, some of the achievements we've had. Then recently we did some migration of the exchange, move it from one location to another. We'll also talk about that. The challenges we experienced while doing the migration. Then we'll also talk about future plans. Then lastly we'll have the Q&A. So KXP was established in the year 2000. At the start, there were only 4 members. Currently, we have around 39 peering members. We are based in 3 locations, 2 in Nairobi, which is the capital city, and 1 in Mombasa, which is the coastal town. Out of these members, 24 of them are internet service providers, 3 mobile and local loop operators, GSM and CDMA. We have a bank. We have 1 government body, which is the Kenya Revenue Authority. We're also lucky to have KNET. We have CCTLD, the root server, which is .ke peering. Then you have the instances of mirrors like FJL, CAM, .NET root servers also. We had a CDN, and we're in talks to get another one on board. So requirements of starting to peer the exchange, there will be a service provider, an ISP, a bank, or one of the content providers, Kenya Revenue Authority, KENIC, or KNET. That's examples of the content providers. Services currently offered, we offer root server multilateral peering. We have peering switches at each location, both offering both layer 2 and layer 3. We also have access to the cache. We're also lucky to run an in-house ISAT program for the members. This is basically for the members only. And last and foremost, we also do the NTP servers. Some of the few policies, peering policies, we currently do both software and hardware routing. Software routing runs on the BAD. Hardware routing runs from a Cisco router. We made a decision to use 2 different equipments just in case we had a bug in one. It doesn't affect our service, we'll still be able to work. The choice on BAD is, we did some tests and bad proved to be the better one. There's a reference link for that. There's a forum that discusses the two, between quagga and bad, which one is easier to use or better one to use. Some of the achievements between 2004 to 2005, if you look at the graphs, we are doing around 900 KB. The growth down there shows you a growth of about 77.8%. Then we moved to 2006. We had a growth of 115.5%, if you look at the traffic growth. When the Google cache was still at the exchange, we're doing probably 1.2 meg. Currently, this is what we have. Currently doing 1.2 gig at peak times. We are lucky KXP will receive around 200 AIS numbers in the world, 50 of them being from the African region. Google cache is currently off at the moment, but we are working to bring it back on board. When that is on board, we are looking at probably growing that traffic to around 2 gig. What else do we have? We have another site, the Mombasa site, does around 500 to 700 at peak times. That's how we looked before we migrated. We're really messed up. That's where we are after migration. That's a switch before migration. Yeah. That's where we are after migration. In the migration currently, we're located in a new data center. Peering is mainly on layer 2. Better thing about moving to a new data center is, for the first time, I think we've had 100% uptime since February 2014. Never had the problem. The cost switch changed to a bit and bigger one. We now on a big iron foundry network switch, capable of handling multiple 10 gigs. Although we've received several orders of 10 gig ports, so we have plans underway to change the gear of the exchange already. Because we need a switch that can handle multiple 10 gigs to probably 100 gigs for connections. Some challenges of the migration. Being a new site, access are a little bit different. Change of IPs to the new site, also we had the issue. There are some members who didn't want to move to the new IP planning that we had. That every client has different needs. Not every member that appears at the exchange is the same. Everybody is different. So you have to incorporate that into one of the challenges. Some lesson learned. Sophisticated Excel sheets were used. Sending this forward between the techies and the management because several versions are the same. The key thing is start early enough in implementing this, probably have a web accessible database or use Google Docs, it works. Some of us used open source, OpenOffice instead of Excel, didn't make anything easier. Clients, they always want to be the last to connect. We had clients connecting as late as the last day of migration. A network freeze could be a good idea, but this is not going to happen as there are always challenges of changing the last mile to the exchange and the testing. So there was no way we're going to add a network freeze. We just had to have a live backup back and forth. Notification being sent. During migration, you could notify, communicate every week to our clients, at least 3 times a week via email and phone calls. All the clients at the exchange knew about the migration, nobody was surprised. This is a key. All is good, everything is tested before, which is really needed. And we managed to keep our initial timeline, which we are targeting by February 14th, which we made. So we are pretty good, we did a good job. Some of the few achievements we've had, we are currently being in one site, in 3 sites actually, 2 in Nairobi and 1 in Mombasa. We changed the route server to software-based one. We've been able to reduce the latency from 1,200 milliseconds to less than 10 for local content. We ran the only SAT program in the country. And some of the achievements that KXP has done to the Kenyan economy are available on that impact study that were carried out by ISOC. The URL is also down there. The challenges we face at the exchange, we still don't have enough local content. E.g., website hosting is not done locally. A good example are the media houses. They say prefer doing the hosting abroad. When you have issues with the 3 submarine cables running into the country, guys get into a lot of problems. Another problem is advertising of routes at the exchange, the way members do it. Aggregation and aggregation of routes. This caused, actually what caused the Google cache to be switched off. Because I think Mike could be talking about this sometime. What you need to do about aggregation, what you advertise to your upstream, you also need to do it to the exchange. Otherwise, there's a little bit of traffic problem going on there. Another issue is always when you want to change IP addresses at the exchange, this is a problem. You are told the person who handles the router is not the same person who has the password or something. It takes a lot of time for an IP address to be changed. Future plans. Future plans, we plan to change the core switches to have a single core switches with different aggregated switches on the 3 sites. Our IPv6 uptake in the region is still not very high, so we plan to encourage members to bring in more V6 routes to the exchange through more trainings, which we are currently doing with Afrinic. Getting financial institutions to start peering to easy transaction in the country. Probably get Akamai and the likes of Ubuntunet onto the exchange, and these are talks that are underway. Akamai could be there before probably the end of this month or earlier next month. Depends. Ubuntunet says they're ready, just waiting for paperwork to be completed. And I think I'm done. I'm open for questions.
Thank you very much, Barry. If 2 or so people can step up to the mic if you have questions for Barry. While we wait for these 2 people to come to the mic, I wanted to ask Barry a question. I've seen some decent growth and decent and progressive growth in the amount of traffic that the IXP has been doing over the years. I'm wondering if there was something that is repeatable in terms of, is it something that can be replicated elsewhere? So the question is, what has been that success factor? How have you managed to sustain the increased growth? Is it probably the service portfolio that you have to offer to members? Or is it probably the business model or something else? What is it that you're doing that other IXPs around the region can do to make sure they get steady and good, fast growth? Thank you. Anyone else with a question? Just move to the mic now.
Well, the key to our success on growth the past few years could be is the way you package the exchange. And I had this conversation with Douglas. Douglas kept telling me, I keep rebranding my switch and packaging it differently. So it all boils down to how you package your product, how you interact with your members, how you interact with the techies of those ISPs in general. That is the key of the growth. How much training you offer them to bring in more traffic to the exchange. That's the key. The interaction is the key.
Any other questions?
Thank you for a good presentation. I'm Matogoro Jabera from Tanzania. I'm also working as the Dodoma Internet Exchange Point Manager. Probably I can just need to have one comment and one question. Internet Exchange Point, to the best of my understanding, has a number of benefits for the African community and to our local people. The African government are putting a number of support on the establishment and the support on the internet exchange point. Also, to the best of my understanding, I think internet exchange point is the way to internet colonialism in Africa. As we have said, we are keeping local traffic local, but most of internet exchange points still need to be connected to the rest part of the world. You find you are taking traffic to Europe and other parts of the world, despite of the benefit that you are getting. But maybe I can just need to get to experience there within nations or country, you might find a country hosting more than 2 internet exchange points. And it came a point of competition on, not is like the right word to use, on where should customers or ISP peer from. For example, let's give my example from my nation, where we are having, the government has planned to, of course we are planning to have more than 5 internet exchange points within Tanzania, where one is located in Dar es Salaam, which is in operational, and we have also another internet exchange point in Arusha, which is also in operational, and there is also internet exchange point located in Dodoma, where is the political capital seat of our nation, which I'm managing, of course. We have the infrastructure since 2009, but they are not used to that point. So maybe I just need to get experience on how many internet exchange points are there in Kenya, and do you have this challenge of ISP saying that we are peering in one internet exchange point? Is there any necessity of the same ISP to peer in another internet exchange point? So that means internet exchange point, the ISP peers, is there any necessity of the single ISP to peer in more than one internet exchange point? That's my point. Thank you.
Owen DeLong, Hurricane Electric. I wanted to respond to some of what the last gentleman said, because I personally think that exchange points are the opposite of internet colonialism. They provide an ability for providers to exchange traffic within region without inviting control and other aspects of traffic management to be handled out of region. They give you an ability to control your own destiny and to increase peering densities within the region, which radically improves your ability to control how you peer, where you peer, and who you peer with. So I don't really understand how one gets to the point of calling an exchange point a route to internet colonialism. I do understand the issue of having too great a density of exchange points. Certainly in a market that can only really support one exchange point, having multiple exchange points is often problematic. In markets where things are not dysfunctional, it is usually possible to find ways for those multiple exchange points to work together and actually form a common layer 2 fabric that is linked among the different exchange points so that they're no longer competing, but they're actually now cooperating. There's no reason for exchange points to be competitive with one another, but in an environment where there are multiple exchange points, there certainly are good reasons for ISPs to go to more than one. There's usually a different mix of peers at each exchange point. There's usually different traffic offload that you can do, and each exchange point tends to develop its own personality over time. And so if you want to serve the greatest variety of customers, you need to participate in the greatest variety of exchange points. Thank you.
Thank you very much. Barry will take this last, and then we'll move on to the other presentation. I think we should have this at the end. After his presentation, we can have another general session like this. Thank you. Barry?
Just to clarify what my brother from Tanzania was saying, the need to peer, like in Kenya, there's only one IXP. We only have 3 different POPs. There's only one Kenya Internet Exchange point in Nairobi, in Kenya. We manage the POPs in Nairobi and one in Mombasa. There are members of the exchange who prefer peering in Mombasa, and there are members at the exchange who prefer peering in Nairobi, depending on what they want to pick. We have a CDN already located in Mombasa. There are some members who are picking this content straight from Mombasa and carrying it themselves. So need to peer in a different exchange depends on what the client wants to pick, on what value he sees on that. But it also depends on how you package your exchange, like I said. Then the idea of having multiple exchanges in the country run by different people, I agree with him totally. Totally doesn't make sense. It's better if you aggregate your traffic at one location or 2 locations. It makes life easier for everyone.
Thank you very much, Barry. We're going to move to our next slide. Mark. We'll have another general discussion. So if you have any issues you want to address, questions or responses, please keep them with you. We'll just get back to that in a few minutes after this presentation. Thank you.
My name is Mark McFadden. I'm from just get back here. Learn how to use this. My name is Mark McFadden. I'm from a organization in the United Kingdom, Interconnect Communications. We do infrastructure consulting, and one of the studies we've done in the last 2 years, 2012, 2013, is a look at carrier-grade net technology and its deployment worldwide. One of the things we were interested in is whether it was successful, how it was used, and also what the implications were. What I want to do in the short time that I have is concentrate on the implications and not so much on the implementation of the technology, which is interesting all by itself, but instead spend most of my time at the end here talking about what the implications are and some of the challenges that come from it. Carrier-grade network address translation, or CGN, is primarily a mechanism by which one can concentrate address utilization by using NAT technology farther up in the core of the network. Basically, the idea is to use fewer public IPv4 addresses on a subscriber basis as a way to conserve those addresses at a time of shortage or at a time of exhaustion. It also allows ISPs to actually grow a subscriber base even in the event where they have no further IPv4 addresses or very few left to go. CGN actually exists under a whole set of names, large-scale NAT, NAT 444, and so forth. So you'll see it under different names. Well, again, one of the things I want to do is very briefly talk about the technology itself, but then spend most of my time talking about the implications. The problem is one that's familiar to this group, and I'm not going to spend a lot of time on it. I was standing in the hall when Owen once mentioned earlier today, he said that IPv4 is history and IPv6 is now, and I agree with that. But there are ISPs who don't believe in that, that actually think that IPv4 is something that they have to take advantage of for a significant amount of time. And when I say significant amount of time, I mean years here. The exhaustion figures here are things that are familiar to everyone in the room. But one of the implications of this is that very, very recently, redistribution of return space from IANA has started to take place. That's an example of the situation that we find ourselves in. And if anyone doesn't think that the IPv4 exhaustion period is upon us, the fact that this policy has started to be implemented is just an example of where we really stand. And if you don't know about the redistribution policy, it's something to actually find out about, because it actually means that the IANA can redistribute very, very small amounts of recovered address space. And when I say the words very small, what I really mean is exponentially tiny amounts of address space. But that redistribution is taking place as we speak. The transition, of course, for getting from IPv4 to IPv6 has been talked about ad nauseum. In fact, I thought Chris did a really good job this morning talking about some of the myths that people face. The fundamental problem is the second bullet, of course. This has been the fundamental problem all along. It's a compatibility issue, and so there are costs involved with doing the migration. Some carriers, some ISPs actually look at this and say, well, is there an opportunity here? Now, if you think about what NATs have meant to us as network providers, as ISPs, they're ubiquitous. They're things that we've taken advantage for a long time, even though in the very early days, there were a lot of concerns associated with network address translation. But essentially what network address translation does is provide a boundary between a public network and a private network, and a translation mechanism so that addresses can be translated at that boundary. There are other things that are going on that people are very familiar with, things like application layer gateways that take place at the boundary and so forth. But fundamentally, what's happening here is providing a boundary between a public and a private network. Now, this is something that we're familiar with. Many people in the room have worked with this for years and years and years, dare I say decades. And of course, on the right-hand side, what we have are installed customers who are behind a private network where we have a device, whether it's in a home or it's in a company's business, that actually provides that border activity, the actual network address translation, any associated activity, for instance, perhaps a firewall activity, and also things like application layer gateways that sit at that boundary on the right-hand side. The public internet sees those as a single address that's connected, a single public address, despite the fact that inside those networks where the blue humanoid figure lies might be hundreds of IP addresses behind that NAT. This is one more of the same thing. Basically, it's detailing in greater depth what that NAT box is doing in traditional NAT settings. And I won't spend a lot of time on this, but the fundamental thing that I want to emphasize here is that a boundary is being set between a public and a private network. Other activities are going on in that NAT, and that's what the text at the bottom is about. One of the things that's going on there is that there is a degree of port mapping that's being used to actually maintain state at the NAT box to indicate what clients are doing behind the NAT box, so that when packets come back, the address can actually be effectively translated. Now, CGN actually provides another layer of NAT in the network. And basically, in the core of the network, what we're going to do is put a second layer of NAT into the network where ISPs are going to share a single IP address with many subscribers. And let that sink in. If you're not familiar with the technology, what it means is continuing to use the existing NATs that delineate private networks that subscribers and consumers have, but instead also put a NAT farther up in the network as a means to actually conserve IPv4 addresses. That means that all the subscribers that sit under the carrier grade NAT share a single IP address. When that means that many, many users, many, many subscribers share that single IP address. It also means that the carrier-grade NAT that's sitting in the core of the network has to do a lot more work, has to do a lot of work in terms of network address translation, state management, and as we'll see, application layer activity as well. Now, I have a couple slides here that are pictures of this. This is the old traditional, basically the traditional picture of NATs. This is a picture that we saw before. Now, this is another picture, actually pre-NATs. These are with no NATs in the network at all, treating each of the subscribers as a publicly accessible IP address. And now here's something that we've been very familiar with for more than a decade, and that is the post-NAT environment where the subscriber or the consumer gets a device that is at the boundary of their network, whether it's in the home or it's in a business, and actually acts as a boundary between public and private networks. Now, this is something that is extremely familiar to us, and compare it with the next picture, which actually puts another layer of NAT into the network. And so basically what we're doing is keeping the same boundary that we have on the left-hand side of the screen here, where consumers and subscribers do have private networks, but beyond that, the ISP also introduces a NAT into the network as a mechanism to conserve IPv4 addresses. It's a mechanism by which they can actually use a single address at that boundary for all of the subscribers that are behind their carrier-grade NAT. Now, at first, that seems like a fairly intriguing and positive development that an ISP could actually move to insert a NAT into their network and still deliver IP services behind it in a way that the subscriber is not affected. As we'll see, it's not quite that simple. Now, the motivation for CGN, I worked for an ISP for quite a while, and the motivation simply in some ISPs is that they are not in a position to deploy IPv6 as quickly as they'd like to. And so what they really would like is a transitional technology, not a technology in the research that we did in 2011, 2012, and then last year. We don't find a lot of ISPs talking about CGN as a long-term technology for them. Instead, what they're looking for is a little bit of breathing space during this transition from IPv4 to IPv6. And carrier-grade NAT appears to be providing that kind of breathing space to a lot of ISPs that are also in parallel ramping up their IPv6 activities. That seems to be very, very common, at least in the parts of the world that we studied. It also means that businesses that are providing services right now can support growth while not having to obtain new IP addresses. And while there was a presentation this morning, I think it was the secret working group that made the presentation, but someone mentioned the fact that in Africa you are IPv4 rich, was the actual words that were used. Not every region of the world is in that situation, and in some regions of the world it's nearly impossible to get any IPv4 addresses. And so supporting growth in your subscriber base becomes very important. You have to have a mechanism for doing that. Now, how is CGN likely to be used? As I mentioned, one of the things that's happening is that we find that ISPs that are having trouble to move quickly for whatever reason, whether it's CPE, customer premise equipment, or it's equipment in the core of the network, or problems they have with management tools, whatever the reason is, ISPs who are in that situation seem to be looking to CGNs as a solution to buy themselves some breathing space. Also, we've seen some large ISPs, especially in Europe and Asia, that find themselves without a pool of IPv4 addresses but still wanting to support growth. And the last bullet on here is pretty interesting and something that I'll talk about a little, but I'll also give you some pointers to some more information. And that is mobile networks find themselves in a completely different situation. Niquainer talked about the mobile internet and the implications for Africa this morning. And I want to emphasize here that mobile networks have been using carrier-grade NATs for quite a while. And the reason is that they're a different beast entirely, a different sort of network than the traditional ISP network. And I have a slide about that in a bit. Now, one of the things that you have to understand when you think about CGNs and their implementation is that one of the things that's happening is that A consumer network in traditional NAT settings is getting a single public IP address. And so, for instance, at my house, one of the things that you find is there is a boundary to my private network, and at that boundary of the private network is a single public routable IP address. With CGNs, that's no longer true. What happens is subscribers, many subscribers, share that same public IP address. And that's a very, very important thing to understand. In fact, address sharing across consumers is fundamental to the kinds of changes and challenges that CGNs bring to the table. And I'll spend the rest of my time talking about that. One of the things that we've seen that is sort of an interesting example of the kind of problem that comes up is, imagine that a bank has in place an anti-abuse regimen where if they find that their website is being abused by a particular IP address, they simply filter that IP address. So here's what happens. In the old world, what we would get was that if they saw abuse from a particular consumer, they would actually block the IP address from that consumer. And then what would happen is, of course, that individual subscriber would be blocked. In the advent of CGNs, where you might have 5,000, 7,000, sometimes even 10,000 subscribers sharing a single IP address, if the bank chose that mechanism for filtering, all of those consumers would be blocked. And so what would happen is that the bank would be blocking service for 5,000 people or 5,000 consumers when only one was causing the problem. So a single bad actor causes a real outage among a large population. And that's because, once again, in CGNs, a single IP address is being shared over a large number of consumers. That's the crucial thing. So anything that depends upon an IP address as an identification tool is going to have real challenges here. Now, I mentioned I'd have a slide about this. One of the things to know is that CGNs have been used in mobile access networks for a long time. And that's because they can. The mobile access networks are a different sort of network than traditional ISPs, for instance, traditional fixed broadband networks. And the reason for that is that, first of all, very few inbound connections come to your mobile handset. So while we're having a revolution, I think, in what mobile devices can do, we still don't go inbound to the mobile device very often. We do in some apps, but not very often. Whereas you think about how traditional internet on fixed broadband works, is that if I want to play some music from a server that I have inside my home, I want to actually get an inbound connection into my home network, right? So the mobile environment doesn't have that. Also, one of the things to know is that mobile networks tend to have very, very tight control on the kinds of devices that are attached to them. That's a real difference between traditional networks, where in a home, what we see is 1,000 flowers bloom. We see a huge number of devices being connected to the network, all sorts, all different profiles, some from sensor devices all the way up to traditional computing devices. So CGNs have been used effectively in mobile networks for a long time, will continue to, it's quite likely, and it's really a very different situation than it is in traditional provisioning of IP services. Now, one of the things I emphasized in my bank example is that address sharing has real implications. Any service that uses an IP address to identify the user is going to fail in this environment. That's a fundamental problem here. And also, there are lots of basic internet services that do require to know in the network, for instance, gaming, to know where another device is without having to go out of the network to find it in. One of the things that we do is that we find that there are many organizations that are developing products that use the IP address to return information that you wouldn't expect would be associated with an IP address. The most common of these, and I think I have a slide about this, would be like geolocation, where I use your IP address to then decide how I'm going to send content to you, or find the closest content distribution network. So there are lots of problems then with sharing IP addresses over a broad range, that is a broad geographic area. Now, I have a good news, bad news story to tell here. There is some good news, and the good news is that there are lots and lots of applications that work just fine with CGN. Things like basic email, basic web browsing, sort of basic utilities that are well understood, perhaps mature. Those things usually work very, very well. Also, client-based applications, rather than peer-to-peer applications, client-based applications tend to work very well. Any service that doesn't rely entirely on the IP address to identify the end node tends to work as well. And so a result of this is that basic internet users, and I pick on her all the time, but my 83-year-old mother would be just fine behind a CGN because she is this profile of user. But my 22-year-old daughter would not be a candidate for this, right? Because she would be using advanced applications, interactions between her tablet, her other smart mobile devices, along with her home network. And so there are really profiles of users for whom CGN works and for whom CGN does not. Now, why do things break? I can't emphasize enough that the key here is address sharing. When we think about gaming networks, whether it is a market-leading console or a competitor of a market-leading console, one of the things they're doing when they set up the gaming system is attempt to find people who are playing the same game as you, as close to you locally as they possibly can, modulo some definition of the word local. If we're all sharing the same IP address, it becomes very, very difficult to find those local connections. And so what happens is that your device, your gaming device inside your local network has to make home runs back to the vendor's network to actually find the location of other people to play. And so there is a tremendous cost in terms of network topology to make those home runs, for instance, all the way to pick on one, to Sony's home network and to come back. Another question is, and I don't have a lot of time to talk about it, but how many ports are available to each user? One of the things that you know is that we use port differentiation as a way to do the translation of the shared addresses into the proper destination for the IP packets. Well, we do that by actually using ports, but if the number of ports that are available is limited, that can have effects on applications. And I talked about, in terms of security issues, I talked about the banking application. I have one more security issue to talk about in a second. I will say this, the IETF's done some outstanding work in this area, and especially I would say the folks in the cable industry have done some outstanding work here. And I recommend to you, if you're interested in this, to take a look at RFC 7021, which is an RFC. It has this long name, assessing the impact of carrier-grade NAT on network applications. But it's really a place to go to find out at a particular point in time what CGNs did to certain profiles of users. It's an excellent document, well written, easily readable, and I recommend it to you. There's a document that was written, 7021 was actually written over a long period of time, but there's another document, RFC 6888, that talks about what to think about if you start to think about putting a CGN into your own network. What kinds of issues, what kind of requirements would you have? And that also is a very good document for pre-planning of CGN implementation. Again, I talked about this before, and I'll just say it one more time. Consumers who use contemporary and advanced applications, for instance, peer-to-peer applications, applications that depend on IP addresses, applications that require inbound connections, tend to really be affected by this. And one of the industries that we found that was significantly affected was the gaming industry, because the consoles tend to have a long life. While we sort of switch ISPs occasionally, someone buys a PlayStation and they stick with it for a long time, or so it seems, due to our research. And as a result, software designers sometimes have to be in a position where they have to redesign their software to cope with NATs in the middle of the network. Let me say that again. What we're doing is we're saying a network provider, an ISP, is actually making a decision, a business decision on its own, that's actually affecting consumers and also software designers. An interesting situation. ISPs do appear to benefit from CGNs. We see they're very, very heavily marketed to, but there are, of course, issues for them. And one of the big issues is logging. One of the things that law enforcement is interested in is they want to be able to find the bad guys. Well, if there's a bad person and they're sharing IP addresses with 4,999 other people, finding them is a problem unless I can actually find which ports I assigned at what time to that particular consumer.